Alright, so I didn't really think I was going to record today because I'm a bit busy with something. But something interesting popped up, and I think it is relevant to talk about. I'm not exactly an expert in the topic because I haven't. Okay, well, to be fair, I haven't mined on a scale um or for long enough. Like I wasn't like an OG miner or something that I know how like mining affects cards, and like I've done all the maintenance and everything. I don't have enough knowledge on mining over a long period of time. So I'm not like one of those like 2014, 13 miners that has like tried mining like on the R9 290 and has been mining or like delved into mining or like off and on mining for the last like however many years. I haven't, so I can't know for sure from actual testing. And there are videos online that try and dispel the like fears and all that stuff. And to be fair, like I think they have good points. I don't think that mining is necessarily a dangerous thing to do in your card. Um, there isn't any real reason why mining should be any more like worse than gaming. Now, I'm not gonna. So I forgot how to configure your card for mining. I forgot like the types of settings you use and stuff. I kind of just can't remember. But I think if I can try and guess, I would say if I go to my afterburner, I'd probably mine. You probably mine around. Give it like yearish in your core. Um, so maybe like your card would be running. Yeah, like this is about correct. So if you see where my mouse is pointing, or like trying to um meet the graph, I'm kind of hitting this point at like 725-ish millivolts, around like 1300 megahertz on this 1080i. Um, I think that's around similar for ampere, but obviously ampere should be able to do higher clocks at lower voltage. So maybe assume this curve is a bit decreased for ampere. I don't know. I can't really recall because I don't have one on hand, but it should be more or less sufficient for the purposes of this like this kind of investigation. So let's say my card was 725 millivolts at or let's say let's do like 1.3 gigahertz at 725. And then we're gonna say the G5X will be running at like, well, if you're mining, you'd run it at the highest you can, and I think mining can tolerate like slightly higher clocks than gaming. Not particularly crazy, but like, let's say if my card game's really stable at 400 on the offset, let's say mining could take 500. So let's say plus 500 megahertz would be what, 6,000 megahertz on the card's memory. So um, 6,000 megahertz on, well, let's just say the data rate because it's more accurate. So 12 gigabits per second on G5X, right? Now, let's say in gaming, I could be running the card at like what I run now, which is like 2.025 gigahertz at 1.05 volts. So quite a step in voltage for gaming. And I run the memory at around, well, the memory rate doesn't really matter that much. The clock doesn't really matter that much. And you don't adjust memory voltage, so it doesn't really matter that much in general. Like, you can't adjust memory voltage, so, well, a normie can't. Like, you can if you have the tools for it, but, like, you can't do it, like, off the bat. Like, you can't just boot up and be like, oh, fuck it, let's go, let's run memory up at, like, 1.3 volts. Yeah, you can't just do that. So, for the sake of this, I'm just gonna, let's not try and be facetious and be like, oh, well, you could be a XOC. Like, let's not do that because it gets very messy, and then you're gonna start, it's just too much semantics. There's no point. There's no real fruit to that approach of things. Let's just make it as basic as possible to make this more um like more streamlined and more like apples to apples, I guess. So let's assume you're just a normie gamer miner. So these are your settings, right, on a 1080i, right? Um, Now you got a full-time miner, and he's gonna be running like he only runs this. Like this is his only this is his only relevant profile. He doesn't care about this. This is like he never runs this. Okay, so the card never sees 1.05 volts. Let's say, for argument's sake, let's say the card he has never been gamed on. Like he never bothered to run at the 1.05 volts. He just didn't need to. He doesn't want a game. He wants to mine. He doesn't care about the clock speed or whatever. Okay, so let's just say that, and then let's say we know that there's a difference between temps in gaming and temps in mining on the components. I'm not totally sure what that is because okay, so now it gets to the part where I can't really help in terms of it's hard to measure overall degradation. Like it's very difficult to determine like what's more detrimental and like which component is like more important that you don't want to degrade. Like oh, because if you degrade the power stages, all the memories power stages have like okay, well technically the memory VRM is much weaker than the core VRM. Therefore, if you're stressing the memory VRM more often than stressing the core VRM, then technically you're more likely to blow a memory power stage. It's like I guess so, but it's like how do you know the like you could see data. So you could, for example, I'm gonna do this, okay? So let's just say for this normie gamer miner, you're gonna say during gaming, his core is at like let's say if he okay, let's say he's like me and he likes taking care of his like temps. He like maybe he opens the card up and he repastes it and he like checks everything and makes sure it's all good and he'll run the fans on his PC at a speed that can actually like push a decent amount of airflow. So let's say he's running this card between 40 and 50 C depending on the game workload, which is very doable in 1080i if you have good cooling, okay? Okay. And let's say the G5X is running at like in a game probably like 55 C to 60 C. So for argument's sake, let's say that because that's somewhat like reasonable. Okay, now let's say for this guy, so let's say for during mining, it'll be the same for both obviously, but for mining, let's say core is going to be running at like nothing. Like it's going to be running, you know, like 725 millivolts. I mean, what is my current card running at? 800 millivolts. Well, there's more workload, so obviously it'll run warmer. But let's just give it 45C. Not even. No, more, no, less because it's running 45 on average in gaming. You could probably do 35C. Like, especially if the fans are running quite quick, you could say even 30C. Depending on how, like, let's say obviously you're mining, so let's say you're not like running the fans at like 28% like I am right here. Let's say you could be running them at like 80%, and now you're running the card at like 30C, 35C. Obviously it gets harder as the ambient increases. Right now we're at like 19 on the weather in my town, so obviously you can't, that gap is harder to close the higher the ambient is obviously. So if you had like 30 ambient you wouldn't be able to do like, you get the point. So and then let's say for mining, let's be reasonable, let's say 70C is the minimum because you're mining. So let's say 70, 75C. I think that's a fairly, although mine's gonna hate me for this, I think this is fair. I think this is reasonable. Like at least a 15C difference between gaming and mining. I think that's pretty reasonable. That's around what I've seen when I used to mine casually on some cars I owned last year. And I think that's a pretty fair like delta. So let's compare. Okay, so what does a 1080 Ti draw mining? Fuck, I don't know. Honestly, I don't know. Let's Google it. Wait, no. Ethereum. There we go. Okay, so you can do 45 mega hashes at 210 watts. Okay, so let's say you were doing 200 watts. So let's say for argument's sake 200 watts. Let's just try and be nice, okay? Let's say for gaming, well, in gaming at 1.05 volts, I draw about 230 watts. I never draw more than that, more or less. Like maybe let's say 230, 250. Like, let's say if you're playing like Cyberpunk, maybe you get 250, but I would say 230 watts. So let's say you're 210 to 210. So the wattage difference, you're talking about like 30 on the min and like 40 on the max, or whatever. Like that's, so what temps do the cards run at? Well, so think about this now. Now this is realistic because if you're wondering, like why is this running? Okay, well, okay, so generally if you've mined, you know that when you game, your core is running at like whatever, like this kind of temperature, and then either you have good cooling, and then your memory runs not that much warmer than the core, usually. Well, it depends if you have Ampere, you know, you might see on a 3080 Ti, your memory might be at like 75C and your core is like at 60C. But Yeah, but that's still 15. So yeah, usually the memory is about 15C higher than the core when you have good memory cooling. Now, if you're talking about the Gigabyte 3090 with 110C of the memory, throw the thing in the fucking bin. Like, I don't know what the fuck they were thinking. Like, that's crazy. Like, that's just no, that's crazy. Like, I don't care what anyone online says. Please, from me, never think that running your memory over 100C is fine. It's not fine. Like, just just don't. Okay, it's not okay. Like, if I'm running my memory at like 80C and you're at 100C, something is going wrong there. Unless my cooler is literally twice the size of your cooler, which it isn't, because the Gigabyte coolers are gigantic. Like, that's just poor thermal transfer. Like, I don't know what the hell happened there, but like, that's not okay. That shouldn't be happening. But I digress. Let's carry on. So, a delta on the core. So, you're running your core, what I would consider insignificantly cooler. Like, in these temperature ranges, I would consider it a nothing burger. It's like, oh, I'm mining and my core is at 30C, and you're gaming and it's at 40C. Dude, mining is not as bad. It's like, no, just no, piss off. Like, no, there's no delta. This is nothing. Like, there's no world where we're running these kinds of temperatures at these kinds of voltages. This is a nothing burger. You don't know why? Because at these kinds of safe voltages, even at like this low voltage and this like medium high voltage, which isn't even high. This is the undervolt, by the way, because the card can run at like 1.09 volts at stock if you want to max out the voltage slider. Literally, like, NVIDIA allow 1.093 volts. You're running 1.05, that thing is not degrading in, like, any... Like, it's not degrading anytime soon. Like, dude, this is being nice to your GPU. Like, understand that when NVIDIA engineer sees you running these kinds of diagnostics, like, if these are your readouts, they're like, damn, this card is running, well. It's running well. But I don't think you could even feasibly like try and think of a way to like, oh, this card could run until 2030, and I think the gaming card might only make it to like 2028, dude. It's like, dude, who's gaming on this card in fucking 2028? No one. Like, what? Like, and even if you were, the amount of degradation you would see is like, dude, a clock bin. Like, I'm talking like, if this is 22.025 gigahertz, you're talking about like, oh, now it's only stable at like 2 gigahertz, and it's 6 years later. It's like, who gives a fuck, dude? Like, come on. Like, so, in terms of core, like this, there's no argument here. There's no argument. Like, there's no thing of, oh, the core runs warmer in gaming. Well, kinda yes, but not really. Like, if you're actually a competent person who runs their fans at a fast enough speed and doesn't allow their card to climb to like 90C while gaming, which is ridiculous, then no. If you're running like slightly higher than a good miner should be compared to a good gamer. Like, you can't compare a bad gamer to a good miner. Like, a miner who runs their cards in an air-conditioned room with a mining rig and a bunch of delta fans and an extractor fan and there's like a fucking massive window behind. No, that's not the normal situation. Like, there are people mining in their basement, right? In their basement with no aircon, okay? As with gaming, there are gamers who do not understand nor care for temperatures or temperature monitoring. People do not always give a shit. But for the enthusiast miner, the enthusiast gamer, even if he's an enthusiast OCer, he knows that there's a range and a means of achieving a safe and optimal, ideal environment for your GPU, right? So it is not fair to compare a decked out miner who knows exactly how to run his cards to a person who doesn't even know, like, what a V-core is. Like, right? Like, you can't compare like that. You have to compare someone who at least knows a little bit about gaming and overclocking and stuff, and a little bit about voltage and silicon and whatever, to a veteran miner who knows exactly how to run his cards. So, if you're talking about the ideal person in both of these camps, you're talking about these kinds of ranges. Like, about 10, 15C deltas on their stuff. And for memory, obviously, you'll have 15C or so in delta in favor of the gamer. And for miners, you'd see 15C or so delta in favor of the miner in terms of core temperatures, okay? And in terms of overall power draw, it's nothing burger, but whatever. Like, let's say about 40 watts delta between a card mining optimally and gaming optimally undervolted. Talking about gaming with an overclock, okay, well, that's probably going to be less efficient, so you could argue there's more degradation there, especially if the card's running at 1.1 volts and running at like 300 watts. Then yeah, of course you can talk more degradation and more heat and stuff. But generally speaking, these two scenarios are very like it's very much not a concern. Like you can't really like look at these two readouts and be like either one of these cards is more susceptible to degrade. Like, how do you measure it? What are you worried about? Like, what number year worries you in these two ideal scenarios? Like, what number year is standing out to you? I guess you could see 75C on the mining memory at worst. Maybe that's like, I mean, I wouldn't even think that this card would run 75. I think it's more like this. I think this is more realistic, to be honest. Like, I think this is more realistic on the 10Ti. I don't even think the difference is that high. I don't think it's 75C for the miner. I think the mining card still runs the memory below 70C on the G5X. As long as there's sufficient cooling. I don't think it's much to worry about. So where do you look then? So where do you look? Where is the degradation? Like, let's look for it. Like, where do we see the scary mining degradation that we hear about, or even conversely the scary gaming degradation? Like, where do we see it? Like, where is it? Well, if you ask someone like Bulldoid, he'll tell you probably on the PCB, which is actually where you should look for most of the degradation. Like degradation for the most part on the core and the chips themselves is not really a concern. Like degradation on your actual GPU die, like that piece of silicon they give you, the crystal, and the actual memory chips made by like whoever, like Hynix or Micron or whoever, Samsung, those components do not fail very often. Like, you do see Ryzen chips especially have memory channel death, right? You do see that. You do see memory chips failing outright. You do see that. You do see memory chips starting to error outright, randomly. You see it on DDR5. DDR5 DIMMs have bad QC. They tend to die. You have DIMMs dying in kits often. I've had DIMMs die on me. So you do see some component deaths and failures, but is that really where you expect the RMAs to come from? No, you don't. It's the PCB. 99% of the time. If you go onto ChrisFix, you go onto Teximetry, like these two channels, I can even show you. Let me show you actually. Let's go there. Let's go there right now, because let's just dispel this right away. Okay, so I like ChrisFix. He's really good. And now let's look at his videos. So if you look at them, like this one mentions copper shims. So in this video, I watched this video. In this video, the person used copper shims. I think something happened where when they installed the cooler, the shim, he didn't exactly explain it, but I think the shim must have put like too much pressure on one of the memory chips because it wasn't exactly the right like height for the contact, and then the chip got damaged. So that happens. So if you do like some sort of cooling modification, you can damage the PCB. So I would consider that more of a PCB damage, because technically the chip is damaged, but it's not really the chip failing. It's not a technical failure. It's more of a I guess you could say like physical damage. Like, so let's consider this. Cards die more via physical damage. Now you're like, so people are dropping their GPUs. No. What I mean is, cards are more likely to die not in like the technical way where like the silicon or the chip starts erroring or like something weird happens within the actual like intricate traces. It's more likely that a massive damage occurs on the PCB via either a short on the power stage that 12 volts to the GPU. Okay, a short, like that's a very common death of a component. It's like a power stage short. The power stage can die. Very, very often it dies. A memory power stage dies and then, takes a chip with it or whatever. Talk about like certain transistors on the PCB. You could talk about like different capacitors, and then maybe like a resistor, for example, in a certain area that like ends up dying. Like, you could have situations where the card can't power on, or the card can't display signal, can't display outputs, like an output signal, or the card can't control fan speed, or maybe it has a BIOS chip corruption, like maybe the BIOS chip itself is damaged somehow or whatever. Like most GPUs that you see that come through channels like this and tech symmetry, and that most RMAs are for, are by and large random mini components on the actual like board failing. So it's almost never like actual like, okay, it sometimes is a chip like that's on its last limb, or like on its last life, sorry, or like maybe the core is it's very uncommon for a GPU or CPU core to actually start like failing. It's very uncommon. It's more, it happens, but it's not like a thing that happens like on every. It's more common that something on the PCB, something small, something that has a known lifespan, something that has um, more of a tolerance for manufacturing imperfections. So like ISL would, like international rectifier, they would maybe not, like some ISL power stages that are very widely used, because there are a bunch of them, and you see them on everything from motherboards to GPU PCBs. Like IR wouldn't have as stringent of a QC, I don't think, as Nvidia or AMD would on their dies and chips, because it's, first of all, it's much cheaper to make a power stage or a transistor or a capacitor, and they make them in such volume that it's probably harder to QC them to as high a degree as like Intel. Like if you watch Linus take this video on Intel's fab, the process of making sure a 1200K is a 1200K is like, it's so crazy stringent, crazy QC that it's like the chances of you receiving a dead CPU are like very, very, very slim. Like it's extremely low. But for a massive factory that's manufacturing like millions of mini, like these tiny, pretty much microscopic components, like you can barely like read the writing on them, with your naked, you pretty much can't, like you're handling these things with a tweezer, so like you're literally trying to like, you can't expect them to, like, in the volume they produce these tiny cheap components that go on the PCB. Unfortunately, you're bound mathematically just have a higher failure rate. Like the fact that you're manufacturing more of them means that you're gonna have a high failure rate. Like more components in the wild are gonna be dead, or faulty, or they're gonna fall kind of sooner on the bathtub curve, right? That's just how it is, right? So unfortunately, because of the fact that they're manufacturing millions of these tiny PCB components, you can assume that more common than not, if your GPU dies, it's going to be a power stage, it's going to be a transistor, a resistor, something like that, that just died, and now it's shorting something, or it's blocking off some sort of signal, or it's taken out a rail. Like now you don't have like 3.3 volt or like 5 volt or whatever. Or maybe if your power stage dies, now you don't have 12 volt or whatever. So the component that dies, it's a tiny component. It's probably one of the cheapest things on that entire board. But now your card doesn't work, right? That's how it is. So with mining and for gaming, it's hard to really like put it into words, because is mining with this kind of a config more stressful on a PCB 24/7, running at consistent temperatures? So let's say the miner is running his PCB at a constant temperature 24/7, but every single PCB component is under stress 24/7 for like 3 years, versus a gamer whose card leverages the core VRM in a different way than a miner does. Right? Like the core VRM is experiencing a different type of load, and the memory VRM with mining is experiencing a different kind of load. So is it worse for the core VRM or the memory VRM? And do the other PCB components care? Like, do they prefer running completely off for like 10 hours a day while like you're sleeping or whatever, or like at school or work, and then let's say you're gaming like 4 hours to 6 hours a day, which is pretty healthy. That's fair. Like 4 to 6 hours is fine. 8 to 10 is a bit crazy. I don't really think that's a thing that happens that often. But let's say 4 hours a day is how much you game. Does your GPU prefer to be completely dead for 20 hours of the day and then be maxed out for 4 hours playing Warzone, for example, with these kinds of settings? Like, that's the question. The real question. Like, let's just put it up. The real question. Does the COD let's say 2 years. Let's do this to make it a bit easier to see, right? Okay, there we go. So, this is the real question. Like, does your card prefer running with these kinds of diagnostics 24/7, or does it prefer being offline 20 hours and then running at these kinds of settings for 2 years? I'm gonna say in brackets for 2 years because we have to try and make it as like, okay, no, I can't do that. Fuck. Let's just do that. Right. So, and I'll do this to make it a bit easier. Let's not say microscopic because people are gonna say power stage is not microscopic. Yeah, that's true. Okay. So let's go like pot by pot. Does the crystal care? No. The crystal gives 0 fucks. Crystal give no shit. This thing does not care. GPU crystal probably doesn't care. Memory ICs. Okay, and now the actual PCB components. There you go. That's your answer. So, that's your answer. That settles it. Technically, the PCB components have lifespans. I can show you if I go Google a datasheet for like something, but like it's irrelevant to the video because you know I'm not lying. Like if you go onto IR's site or if you go onto whatever like what's another company, Renaissance. If you go Google any power stage or any resistor or transistor, whatever you want to Google, like you can Google anything. You'll see that there's a lifespan. There's a limited lifespan. It says something hours at something degrees Celsius. Now that does mean it's going to last a long time. So I'm not saying that they really hate mining. I'm just saying that they probably do care. They probably would prefer to be offline for 20 hours. Because if you're gaming under these very ideal conditions for 4 hours a day for 2 years, they probably won't lose as much lifespan as if you had just used them 24/7. Even a low level of stress, they aren't really that much more stressed gaming, or even they aren't even really more stressed gaming than mining necessarily, but they have a limited lifespan and they do run a certain temperature. So if you're going to be gaming 4 hours a day versus mining 24/7, yeah, inherently you're going to be degrading your PCB more. It's just logical. There's no real you can't really come to me like, oh, dude, you're lying. I mean, how could I be lying? Like, how could I be embellishing? Like, this is just a fact. Like, it's what do you want me to say? It's true. Like, the crystal's like, I'm giving you a lifeline. The crystal doesn't care. Like, the crystal is like, oh, fuck it, dude. Like, 725 millivolts, 24/7. Fuck it. Like, that's nothing. Gaming 4 hours, 1.05 volts. Okay, now it's like, oh, okay, you know what? The crystal is like, either or. I don't care. I'm not gonna degrade. But you know what? They're both pretty much equal stress, so whatever. Like, it's, it's like whatever. Like, I guess there's no difference. And then the ICs, like again, they probably don't care, but they probably would be more susceptible to degrading if run 24/7 at like a higher operating temperature, like when you're mining. So that's your answer. Like, if anyone thinks I'm lying or talking shit, like feel free to make a counter video or like comment and tell me I'm an idiot. But I don't really see how I've done a bad job. I think I've been pretty. This seems like a pretty fair like this seems very very reasonable. Like I don't really see any holes in this. Like genuinely, like I'm not looking at this and be like, oh, something here doesn't look. Nah, this looks pretty much spot on. So yeah, hope you guys enjoyed this video and please do share your opinion. Like I'd be interested. But yeah, cheers guys.